All right, so here we are. We're going to talk about water, chemistry, and life. The chemistry of water is how we manage to stay alive, how we can be full of life, how we can do the things that we do that keep us from falling apart. Water is amazing. And the main reason water is amazing has to do with the way it's built. You see, when it comes to chemistry, anything that isn't a single element like cobalt or iron or carbon or hydrogen is formed with a bond between two different molecules or between two molecules. And those bonds between molecules, remember, an atom is the smallest size of particle that has its normal characteristics. When those atoms come together, they're bonded together in one of three ways. And they're either an ionic bond, a covalent bond, or sometimes they're bonded by these things called van der Waals forces. Now, an ionic bond is basically when two atoms get together and one of them actually gives an electron to the other atom. Now, electrons have a negative charge. So when the electron leaves this particular atom, it goes from being neutral to being positive because it lost that negative charge. The one over here gets the electron and it goes from being neutral to being negative. Now, when you've got a positive magnetic force and a negative magnetic force next to one another, they stick together. The magnetism holds them together. And an ionic bond, that magnetic force attracts those two together. A covalent bond is a little bit less of a commitment. What happens is that the two atoms, instead of one giving an electron to the other one, they agree to share that electron. A covalent bond involves sharing the electrons, the two atoms sharing those electrons, and it becoming a part of a group of electrons that they both have. So we've got the ionic bond actually holds them together. Covalent bond actually holds atoms together. A van der Waals force is basically the idea that sometimes when you've got multiple atoms together in a molecule, parts of that atom, they're not really negative, but they're kind of negative. Or they're not really positive, but they're kind of positive. Because remember, the center of an atom is the nucleus. And that nucleus of the atom is then surrounded by all these electrons around it. The electrons are more like planets going around the sun, orbiting around this nucleus. Well, when you have atoms that are bonded together in a molecule, they share the orbit. So the two centers are reasonably close to one another, and all of the electrons that they're sharing, well, they kind of spend some time around this center and some time around this center, flowing in circles around them both. Sorry for anybody who gets motion sickness easily about that hand gesture. But the idea is because these electrons are shared, they don't spend equal amounts of time everywhere around the molecule. They spend more in one place, less in another, and that causes sometimes some parts of the molecule to be more negative or more positive. Specifically, where we see this happen that's important for what we're doing is in water. Now, up here on your screen, you can see, looking up there, that we have a model of a molecule of water. Remember, what's water? It's H2O, two hydrogen atoms and one oxygen atom. H2, hydrogen 2, O, oxygen 1. So up there, you've got one oxygen with two hydrogens, and they're all stuck together. Now, the kind of bond that you've got in water is a covalent bond, so they're sharing the electrons. And that sharing of electrons, what happens is they're orbiting around and spending time at both ends. Now, because now the thing is that the side with the oxygen is a little bit negative, so it's not really negative, but it's kind of negative. The side with the hydrogens is just a little bit positive, but not actually positive. And that polarity, that kind of negative on one end, kind of positive on the other end, is part of what gives water so many of its special features.